Hi, and welcome to day 2 of rational expressions. Today we are comparing rational expressions. We're not going to use the slips of paper that it says there, so we'll just start right in the exercises here. We will start by working with positive integers. Let m and n be positive integers. Work through the following exercises with a partner. Well, I'm your partner. Fill out the table. So I'm just going to substitute in n into this fraction, 1 over n. Oh, hang on. Okay, so when I put in 1 for n, I end up with 1 over 1, which is just 1. When I put 2 in for n to this fraction, I end up with 1 over 2. Don't like how that looks. Go right over here. 1 half. Then when I put 3 in for n, I have 1 third. And when I put 4 in for n, I have 1 fourth. And when I put 5 in for n, I have 1 fifth. And then when I put 6 in for n, I have 1 sixth. So, using this chart, do you expect 1 over n to be bigger or smaller than 1 over n plus 1? Do you expect 1 over n to be bigger or smaller than n plus 2? And explain why. Well, when we're talking about fractions, one thing we have to understand is the larger the denominator, the smaller the fraction. So, as n increases, our fractions actually get smaller. So we can say as n increases, one over n decreases. This means sorry about that. This means that if you add 1 to n, then you will get a smaller number. And that's because the larger the denominator, the smaller the fraction. So that is 1 over n would be greater than 1 over n plus 1, which would be greater than 1 over n plus 2 in the end. So I would expect 1 over n to be bigger than 1 over n plus 2. Because remember, as the denominator increases in size, the smaller the fraction goes. Compare the rational expressions 1 over n, 1 over n plus 1, and 1 over n plus 2 for n equals 1, 2, and 3. Do your results support your conjecture from exercise 2? Revise your conjecture if necessary. Well, if n equals 1, then we would have 1, which is larger than 1 half, which is larger than 1 third. All I'm doing is substituting in 1 for n here. Now I need to do the same thing with that too. So if n is equal to 2, then I'd have 1 half, that's supposed to be a colon, is greater than 1 third, which is greater than 1 fourth. And then if n equals 3, then I'd have 1 third greater than 1 fourth, greater than 1/5. So that's not going to change what we said from the problem above, because every time I add 1 to the exponent, my fraction gets smaller. Or sorry, exponent to the denominator, my fraction gets smaller. So, do your results support your conjecture from exercise 2? Yes, it does. 1 over n is greater than 1 over n plus 1, which is greater than 1 over n plus 2. Alright, next page. From your work in exercises 1 and 2, generalize how 1 over n compares to 1 over n plus m, where m and n are positive integers. Now remember, positive integers would be whole numbers in this case, because an integer is positive and negative whole numbers in 0. And if we're talking positive, we're not including 0, we're not including the negatives, we're just including positive whole numbers. So since m is a positive integer, being added to n, the denominator is going to get bigger. So the denominator will increase. And you'd say then which will decrease the value of the rational expression. So overall, 1 over n would have to be greater than 1 over n plus m for positive integers. N and n. I'm not really sure why it's taking the dot from my eye and connecting it to the end of my words, but I don't think I'm picking up my pen far enough. Sorry. So basically what that problem is saying is that if you have a fraction and you add another positive integer to your denominator, your fraction is going to get smaller because your denominator is going to increase. So remember, the larger the denominator, the smaller the fraction. Will your conjecture change or stay the same if the numerator, is 2 instead of 1? Make a conjecture about what happens when the numerator is held constant, but the denominator increases for positive integers. Well, if you're keeping your numerator at 2, it's really not much different than 1, and your denominator is going to keep getting larger. So again, the larger your denominator gets, the smaller your fraction gets. Since you're going to keep the numerator at 2, it's still going to be a fraction that's a proper fraction, and it's still going to be a larger number. So my conjectures will stay the same. Okay, for example 1, we're just going to fill out the chart together, and then in class we'll pick up with the rest of the activity that kind of goes along with this stuff. So if I put in 0.5 for x and I use my calculator, so we're going to use the calculator and complete to 4 decimal places. So if I substitute in 0.5 for x here, I am going to get 3. If I substitute 0.5 into my other fraction, I get 1.6667. If I substitute 1 into my fraction for x, and I simplify, I will get 2. If I substitute 1 into this fraction for x, I will get 1.5. If I put 1.5 into this fraction, I will get 1.6667. And if I substitute 1.5 into my second fraction, I will get 1.4. If I substitute 2 into the first fraction, I will get 1.5. If I substitute 2 into the second fraction, I will get 1.3333. If I substitute 5 into the first fraction, I will get 1.2 for the first fraction, and that 5 for the second fraction will give me 1.1667. And if I put 10 into the first fraction, I will get 1.1. And into the second fraction, I will get 1.0909. And finally, if I put 100 into this fraction, I will get 1.01. And into the second fraction, 100 would be 1.0099. So we're going to look at that chart in class, and we're going to make some comparisons, and we're going to make some conjectures.